Hi, and welcome to day 4 of polynomials. Today we are going to be comparing methods and doing long division again. So the first thing we're going to do is review the reverse tabular method to determine the quotient. And remember yesterday we wrote the x and the 5 on the outside like that. And then what would be on the top of the fraction will go on the outside. So this is 2x cubed, and that would be going there. And this is 11x squared going on that diagonal. And then this is 7x on this diagonal, and in this last box would be 10. And we know that this, it needs to be 2x cubed, and we know this needs to be 10. So now we need to fill in our other places. So what do I multiply x by to get to x cubed? Well, that would be 2x squared. And when I multiply 2x squared by 5, I get 10x squared. And since this diagonal right here needs to add up to 11x, if I have 11x squared, if I have 10x squared here, that means this has to be a 1x squared. So what do I multiply x by to get 1x squared? Well, I multiply it by x. And then I multiply x times 5, and I get 5x. And since this diagonal here needs to be 7x, 5x plus what gives me 7x? Well, that would be 2x. What do I have to multiply x by to get 2x? That would be 2. And 2 times 5 is 10, and that's what we said needed to be there. So the answer is 2x squared plus x plus 2. All right. So use your work from exercise 1 to write the polynomial 2x cubed plus 11x squared plus 7x plus 10 in factored form. Then multiply the factors to check your work above. Factored form. Remember yesterday in the notes I said it's factor equals the product. So the two things we multiply together are our factors. So if we are going to check the work, the two things that we need to multiply together are our answer and the x plus 5. So our answer is 2x squared plus x plus 2, and then x plus 5. So we just need to do the box method from the other day. So x times 2x squared is 2x cubed. X times x is x squared. 2 times x is 2x. And then 2x squared times 5 is 10x squared. X times 5 is 5x. 2 times 5 is 10. So going this way on the diagonals, it's 2x cubed. Adding up, I have 10x squared and 1x squared, so it's 11x squared. On this diagonal, I have 2x plus 5x, which is 7x, and then this is just 10. So I have my 2x cubed plus 11x plus 7x plus 10 as my outsides here to show that it works. Okay, next page. So if x equals 10, then the division 1,573 divided by 13 can be represented using polynomial division. So it's a little bit harder to understand this if we just jump right into x equals 10. So I'm going to go back to what you learned probably in about 5th grade, 4th or 5th grade, and do long division. And I'm going to do 13 divided by 1,573. And when we divided here, 13 went into 15 one time. 1 times 13 is 13. And then I subtract, and I have 15 minus 13, which is 2. And I bring down to the 7. So then I have to ask myself, how many times does 13 go into 27? Well, 13 goes into 27 2 times. There is 2 on top. 2 times 13 is 26. And then I subtract. I get a 1. Bring down my 3. 13 goes into 13. 1 time. 1 times 13 is 13. And my remainder is 0. Now I can do that same exact process using polynomials. I have 2 terms here. That means I need to go over 1, 2 terms over here, and I put a little dot. And that's where I'm going to write my very first answer. And I always look at the front terms only. And the x cubed would be the front term here. And I asked myself, what do I have to multiply x by to get x cubed? And the answer is x squared. So then I need to multiply this x squared times x plus 3, just like we did 1 times 13 or 2 times 13. But we have to use our distributive property, and we're going to say x squared times x plus 3 and actually distribute that out. So x squared times x is x cubed, x squared times 3 is 3x squared. So I'm going to write that down here. So x times x is x cubed. X squared times 3 is plus 3x squared. Now I need to subtract, because that was the next step. And I need to put parentheses around the whole thing. And I'm going to subtract that whole polynomial. So this becomes a negative x cubed, and this becomes a negative 3x squared. Now my x cubed and my negative x cubed cancel each other out. 5x squared and a negative 3x squared is now 2x squared. Then I bring down my 7x. Then I ask myself again, going back to that x, what do I multiply x by to get 2x squared? Well, I'm going to multiply it times 2x. So plus 2x. So 2x times x is 2x squared. 2x times 3 is 6x. And then I need to subtract the whole polynomial. So everything on its inside changes to its opposite sign. The 2x squareds cancel out. So I have 7x minus 6x, which is now 1x. Bring down the 3. What do I multiply x by to get 1x? Well, that'd be plus 1. 1 times x is x. 1 times 3 is 3. Now they match. Everything looks exactly the same right now. So when I go to subtract, everything's going to change to its opposite, and I'll have a remainder of 0. And they're asking in the actual problem, if x is equal to 10, then we should divide. And if I were to take my answer as x squared plus 2x plus 1 and put in 10 for x, I have 10 squared plus 2 times 10 plus 1. So I have 100 plus 20 plus 1. So my answer is 121, which is exactly what we had over here. And if you look at that carefully, it's exactly what we have here. My x squared is representing my hundreds place, my x is representing my tens place, and 1 is representing my units place. And that's just a quick check, that's all. Use the long division algorithm for polynomials to evaluate. I have 2x cubed minus 4x squared plus 2. Right in here, I'm missing an x term, and I have to include that when I go to divide. So I have 2x minus 2 on the outside, and then on the inside I have 2x cubed minus 4x squared plus 0x plus 2. I have to include what I call a placeholder for the 0x. or else it will not work. So I have two terms over here. I need to go over two places here. And I ask myself, what do I multiply 2x by to get 2x cubed? Well, that's just x squared. X squared times 2x is 2x cubed. X squared times negative 2 is negative 2x squared. Now I need to subtract everything. So subtract that. This subtraction then changes to an addition. So my 2x cubed cancel out. I have negative 4x squared plus 2x, and negative 4x squared. Bring down 0x. And I ask myself, what do I have to multiply 2x by to get negative 4x? Well, actually, I should be 2. Ooh. I have to multiply it by negative x. So negative x times 2x is negative 2x squared, and negative x times negative 2 is plus 2x. So again, I need to subtract. I have to subtract the whole polynomial, so I have to change everything to its opposite inside. So the 2x squareds cancel each other out, and then this is just negative 2x. And then I bring down my plus 2. What do I multiply 2x by to get negative 2x? Well, that would be minus 1, not plus 1. Minus 1. So negative 1 times 2x is negative 2x. Negative 1 times negative 2 is plus 2. And I need to subtract that, change all my signs to opposite, so everything cancels out. So my remainder is 0, so my final answer is x squared minus x minus 1. That says for you to try. I'd like you to try and have a few of these done before you come to class. I would like to see number 1 done. I would like to see number 2 done. And number 3 I'd like to see done. But remember, you're missing some terms in here. So that one will look like x minus 3 divided by x cubed plus the x squared term is missing, so 0x squared plus the x term is missing, 0x minus 27. So that's what it's actually going to look like when I go ahead and set up my long division. All right. I'm going to not assign you anything else right now. I just want you to try those 3 on your own before class, and then we will go over them.